Hi, I'm Lindsay.
And I'm Marshall. Welcome to Tumble, the show where we explore stories of science discovery.
Today we're going into the eye of a hurricane.
Oh gosh, we're traveling into the middle of a hurricane? That sounds really dangerous, and I didn't bring anything to protect me.
Well, it's okay because we have a real-life hurricane hunter as our guide through the storm, a scientist who spent her whole life flying directly into hurricanes.
Wow.
Today's question comes from Tumble listener Lydia.
Hi, my name is Lydia, and my question is, why doesn't the eye of a hurricane have any strong winds like the rest of the hurricane does?
Okay, so, I know hurricanes have an eye, but can that eye blink?
Lydia has her own theory on why it's calm in the eye of a hurricane.
I think the answer is that the winds are circling around one spot, and I think the scientists will find out by using their very cool scientific tools.
That's a pretty solid theory, and very cool scientific tools like a science hammer are really great ways to find stuff out.
A science hammer?
Yeah, a hammer you use for science, like to bonk on things.
I don't think that exists. But let's ask our listeners what they think the answer is. And how would scientists find out? Think about it, because when we come back, we'll be talking to a scientist who studies hurricanes by flying right into them.
So we're going to be talking to a hurricane researcher. Would that be a hurricanologist?
Not quite.
My name is Shirley Murillo. So I am a meteorologist, which means I study the weather. And more specifically, my field of meteorology that I study is hurricanes, also known as tropical cyclones.
Wait, aren't meteorologists like the weather people on TV who tell you whether it's going to rain, and I guess also whether it's going to hurricane?
They are, but Shirley Murillo is not that kind of meteorologist. She spends her days flying into hurricanes.
I get to fly inside a Hurricane Hunter aircraft. That aircraft goes right into the inside of the storm.
Flying into a hurricane? We've gone a long way from predicting the weather on TV to flying directly into a storm. How did Shirley become a hurricane hunter?
Well, it goes back to when she was growing up in Miami, Florida, a city that gets a lot of hurricanes.
I was 16 years old, 16 years old, when I heard that Hurricane Andrew was going to be a threat to South Florida. And I thought, wow, my family has to prepare.
Hurricanes can be pretty scary. The winds and rains can do a lot of damage. So Shirley and her family did as much as they could to protect themselves before the storm came in.
We bought water, we had extra batteries, flashlights, all that sort of thing.
Once the storm started, Shirley and her family hunkered down in their house to wait for it to pass.
We were in our home, and you would hear the rain and the wind and things being tossed around. We had lost power. That was my first experience seeing the power that nature can hold. I remember once the storm had passed and going out, into my yard, and I saw the cover of a streetlight. And it looked like a giant red bowl. And I'm like, what is this?
A giant red bowl? Like a giant bowl of ketchup or something?
No, it was actually the cover to a streetlight. The ones that have red, yellow, and green lights for cars.
And to actually see it, I was like, wow, this thing is really big. It almost fits my face.
Well, it would have to be a pretty bad storm to be able to carry a streetlight all the way to Shirley's house.
Yeah, seeing how much damage the hurricane did motivated Shirley to study them.
I wanted to help people by understanding how hurricanes form, how we can warn people, how we can protect lives. That is what started my path into a career in meteorology.
In fact, she became kind of hurricane obsessed.
I became, really enthralled with them and wanted to learn about where they form and all sorts of things.
So when it came to deciding what she would study in college, it was kind of a no-brainer. Shirley became one of the only Latinas in meteorology at her university.
I went up north to go to school, and I was away from my family for the first time. It wasn't something that my parents were used to or in their culture, and for them to just have me move away and leave, it was very different for them.
Shirley was learning a lot about hurricanes, but she also felt alone.
It felt very isolated at times.
But eventually, Shirley did find a group of students who helped her feel like she belonged.
I met people that looked like me from all other parts of the U.S., and I was like, wow, they're going through the same thing.
Well, it's awesome that Shirley found a community.
Yeah, it made the process of becoming a meteorologist a lot easier. But Shirley never shies away from a challenge. So when she heard that there was a job that let you actually fly into a hurricane, she jumped on it.
I got involved as soon as I could because I wanted to learn. That was part of what the scientists were doing. And if I was going to be one of them, I needed to do that too.
Wait, so her mom was like, if all of your friends flew into a hurricane, would you do it too? And I guess her answer was yes.
Yes. Shirley wanted to be in on the action and getting hands-on experience. So in 1998, she put on her blue flight suit for the first time and climbed aboard a specially equipped plane called a Hurricane Hunter.
How do you equip a plane to hunt a hurricane?
Yeah, so our plane is like a flying science laboratory. So imagine there's a lot of racks, metal racks with computers that are in each side of the plane.
Okay, I mean, I'm going to guess the racks are like pretty well secured to the wall.
Yes. And the computers on them are helping keep track of all the data being collected.
So we go into the storms because our aircraft is equipped with many instruments that can gather information inside the hurricane.
The Hurricane Hunter plane is designed to collect data about what's actually going on inside of the storm, something that meteorologists can't get any other way.
Okay, but how does it feel to actually fly into a hurricane?
It feels like a roller coaster. And the plane is also loud. The engines are roaring, so the plane is really loud inside. We wear headphones, so even though I'm sitting next to my coworker, it's not easy for me just to lean over and tell them something.
Okay, so you have to yell at your coworker while riding on a roller coaster and collecting scientific measurements with computers that are bolted to the wall. And if it were me, there'd probably also be throwing up.
Oh, that happens sometimes.
Okay.
I'll admit to that I have gotten motion sickness several times.
So I'm going to say that hurricane researcher is not a job I'm going to go for, even though I'm just finding out about it.
Yeah, it would be a big switch from podcaster to hurricane hunter for you.
You know, there's always a possibility.
Well, for Shirley, being able to do hands-on research makes flying through hurricanes totally worth it.
To me, when I got to see the storm, the cloud formations, it felt like everything that I learned on the textbook came to life. There was nothing like looking at the formation of the eye wall, the rain bands.
Okay, so it sounds like Shirley is the perfect person to answer Lydia's question about why there aren't strong winds in the eye of the hurricane, because she's been there in a plane.
Exactly. That's why we called her.
So what did she say is the answer?
Well, she said, first, we have to understand how a hurricane forms. And it's kind of like baking a cake.
So there are ingredients that you need for a hurricane to happen. You need a warm ocean, you need warm, moist air, and you need a cluster of thunderstorms.
Well, look at this. Let me just reach into the back of the pantry and, we got some warm ocean in here. We got warm, moist air and a cluster of thunderstorms. I didn't know you kept all this stuff in here.
I love to stock up. But you're missing one more special ingredient.
Baking soda.
No, it's wind.
So the wind at the sea surface and at the top of the atmosphere, they cannot be too different. They cannot be too strong and not too weak.
Oh, so it's like Goldilocks wind to make a hurricane.
Yep, you need the wind conditions in the atmosphere above Earth's surface to be just right.
When you have all these things together, the cluster of thunderstorms march along together, and there's a spin in the atmosphere, and that causes a hurricane to grow.
Mix that all together, and you've got the recipe for a hurricane.
So we've got a hurricane, but where does the eye come from? Because most cakes don't really have eyes.
Well, one cake has a hole in the middle, and that counts.
Imagine if you were a bundt cake.
Okay, so you could say that the middle of the bundt cake is like the calm at the center.
Yeah, it's kind of like if you overfilled your bundt pan with batter, and then the batter started sliding down the hole in the middle. It's looking for a place to go. Well, in a storm, the thunderstorms are forming the walls of the eye, and it traps air inside. The air sinks down.
So now you're seeing this sinking happening. And so then all of a sudden in the center of the storm, when we have calm air, the pressure there is lower.
Oh, I get it. So the air pressure at the center of the storm is lower than all the air around it. It's like a little oasis in a ring of thunderstorms.
Exactly. And that's what makes the air at the center of the hurricane calm or less windy.
So what can this missing hole in the center of the hurricane tell us? Like, why not focus on the cake part around it? Because that's definitely tastier.
I know, that's the part of the cake I'm interested in. But the eye of the hurricane can tell us some pretty important things about how intense a storm will be. We'll find out what Shirley discovered when she was flying through one of the most impactful hurricanes in American history, Hurricane Katrina.
Wow, she flew into Katrina?
Right into it, and we'll get right into that after this quick break. We're back. So now that we've found out how to fly through a hurricane and bake a hurricane, let's find out about Shirley's biggest storm, Hurricane Katrina. The year was 2005, and scientists were tracking a storm forming in the Gulf, headed towards the city of New Orleans.
I had a feeling that this was going to be a major event.
I remember that. That was a scary time.
Even early on, scientists could tell Katrina was going to be a big one.
The computer models at the time were predicting that the storm would rapidly intensify.
Which meant it was time for Shirley and her team to suit up and get their plane ready to fly in to collect data. They spent days studying Katrina, tracking its path. And on every trip, Shirley took careful notes, trying to figure out what was different about this storm.
When I do my flights, I put myself in a Sherlock Holmes hat, and I think, I want to see what this storm is going to tell me. I feel like I'm a detective, and I'm trying to put the pieces of the puzzle together.
Man, and I thought jigsaw puzzles were hard, and I've never done them in 400-mile-an-hour winds.
Exactly. Shirley uses every data point like a clue to help her understand how intense the storm will be and which way it will go. And all the clues were pointing towards the storm going from bad to worse.
So when a storm rapidly intensifies, it goes from one category to 2 to 3 in less than 24 hours.
Categories are how scientists classify how strong a hurricane is. Category 1 is the weakest and 5 is the strongest. And Katrina was quickly moving up to Category 5.
Yikes. Even I can tell what that clue means.
Yeah, and one of the other clues was something that happened to Katrina's eye. It was replaced.
Katrina made what we call an eye wall replacement cycle.
Whoa, replaced? Replaced with what? Like more bundt cake?
No, with a new eye.
Ooh, a googly eye.
Not quite. Eye wall replacement is actually the way that the strongest hurricanes keep up their energy.
So that means that the current eye and the eye wall all of a sudden starts to get wide.
In the biggest hurricanes, there's many rings of thunderstorms that circle the eye. The inner storms are right around the eye wall. But In these big storms, another ring of storms are pressing in on that inner circle, trying to get in.
And so all of a sudden, those rain bands around the eye or outside of the eye wall gather enough strength.
Eventually, the outer ring of storms gets in and collapses the eye, and then it grows a new one.
And so, the storm speed slowed down, the eye started to expand, and a new eye took over.
Well, that sounds intense.
The eye wall replacement was the strongest clue that Katrina was going to make a really big impact. So once Shirley and her team realized how big Katrina would be, they did their best to share the information to scientists on the ground so they could make sure that people stayed safe.
We were seeing the data, sending that data to the forecasters, watches and warnings were going up, and we just were hoping that people were making the right decisions to protect themselves as the storm was making landfall.
It's one of the most important parts of Shirley's job, turning all the scientific data into information for people in the path of the storm whose lives will be affected.
Even though, I'm there maybe being a science geek, gathering data and seeing equations come to life, knowing that information is going to trigger someone to take action or make a decision to protect themselves.
Well, that information can definitely save lives. I remember when Katrina happened, and it was devastating.
Absolutely. It reminded Shirley of how she felt after Hurricane Andrew.
Because I was there too when I was a teenager.
She remembered why she had wanted to become a meteorologist in the first place, to help people better prepare for hurricanes.
For me, when I talk to my colleagues, we can talk about all these things and equations and parameters and things about the inner workings of hurricanes. But at the end of the day, it's what people are going to do with that. What, your neighbor or your grandmother, how are they going to prepare? What actions are they going to take?
Yeah, so I guess she's saying it's great to have and discuss all the data, but the most important part is what people do with it.
Exactly. So Shirley says what she's learned from flying through hundreds of hurricanes is to always keep learning.
This experience has taught me that science is always evolving. So every hurricane that I fly is something new. I always learn something new.
Let's check in with our question asker, Lydia, to see if she learned something new from Shirley.
I learned that the eye of a hurricane forms because of low pressure in the center, and I don't want to be a hurricane hunter because flying into a hurricane is scary for me.
Me too, Lydia. I think I'll leave the hurricane hunting to Shirley.
Same.
Now that you've heard about Shirley's adventures flying through hurricanes, decide for yourself. Would you want to be a hurricane hunter? If yes, why? Or why not? If you're like me and have no stomach for turbulence, what kind of weather would you want to study and how?
Talk about it with your family, friends, and classmates. Then draw a picture of yourself doing your research, along with the science questions you want to answer. Send it to us at tumblepodcast@gmail.com, and maybe we'll help answer your question in a future episode. Thanks today to Shirley Murillo, research meteorologist with the Hurricane Research Division, part of the Atlantic Oceanographic and Meteorological Laboratory at NOAA.
Visit our website at sciencepodcastforkids.com for lots more resources about her work.
This material is based upon work supported by the National Science Foundation under grant number 2415575. Culturally situated STEM podcasts for kids. Special thanks to our research and cultural editorial team, Dr. Remy Du, Yasmin Catracheo, and Noria Netz.
Sarah Robertson-Lentz is our managing editor and designed the episode art. Chad Chennai is our assistant producer. Gary Calhoun-James is our engineer and mixer. Jasmine Romero wrote this episode. Vanessa de la Cruz was our researcher and interviewer.
I'm Lindsay Patterson, and I'm the executive producer and editor of this show.
And I'm Marshall Escamilla, and I made all of the music and sound design for this episode. Tumble is a production of Tumble Media. Thanks for listening, and stay tuned for more stories of science discovery. Hey everybody, here we are at the end of the episode, and that means it's time to wish some happy birthdays to our supporters on Patreon. But before we get there, I got a special shout out for Etta B, who joined us as a new supporter. Thanks so much, Etta. Now, on to the birthdays. First, a happy birthday on April 26th to Alex. Mommy, Daddy, and Grayson love you. A super happy birthday to the great Elena on May 1st with much love from Nana, Pop, Aunt Lindsay, and Uncle Marshall. I wonder who those could be. Tanisha, happy birthday on May 2nd. Your family is so proud of you and love that you love science. Mommy, Daddy, and Ading Rajitha love you so much. A happy May 4th birthday to Talise. Mom and Dad send you big hearts from their hearts. They love you so much. A happy May 5th birthday to Lydia. Keep exploring. Maybe this year you'll find a baby space dinosaur fairy under a mushroom. And if you do, you really should publish about that because it would be like a major finding and we'd probably talk about it on our show. Felix, your parents love you and are so proud of your boundless curiosity, and a happy birthday on May 6th. Thanks to all of you and to everyone who supports Tumble on Patreon. If you want to get a birthday shout out of your own like these fine folks, simply support Tumble on Patreon at the $5 level or higher by going to patreon.com/tumblepodcast. Or if you're on Spotify, just tap the subscribe button. It's right there.